We're here to discuss the final project. Um, you're going to find under the final project, you'll find the instructions. And let me go back to that just a little bit here. The inventor final, um, you're going to be given customers sketches. This is very real world where you'll be given some information, concept, whatever, and you won't be given CAD drawings. You'll be given some sketches. If you're lucky, you'll get them in the format that I've given you. Most of the time, it's on the back of an envelope or on a napkin. Um, but I made this as realistic as possible. You're not going to be asked to do anything that you haven't done throughout the class and been prepared for. Um, this is to develop a working model for a wood rack that will hold a half a cord of firewood. If any of you have a fireplace or have had a fireplace in your house when you were growing up, you probably had a place to store at least a half a cord of firewood. Um, it's going to be in 3D assembly. Um, and this is a typical project where you encounter a hand sketch either from a customer, a shop worker, a manager, someone that has an idea and they want to project this to you, and you've got to put it into a 3D model in CAD. I've given you a partial material list, which I will show you, some notes, and you're going to use the frame tutorial that you did to develop a one-line diagram, model the components, and create the drawings. So let's go into what you've been given, and I've given you quite a bit here. So first I've given you the basic sketch that the customer came in and gave. Um, and it's a one-line diagram. So it's overall, the rack height is 50 inches. It's 99 and a half center to center, and that means to the center of the upright. And you notice it's got part numbers for material list and some details. So I've got a detail A and detail B. So let's move down. This is an elevation view or a front view of this rack, and it's basically 100 inches wide by 50 inches tall. And you've got supporting members here, which you'll see. Item 2 is 3 by 4 by 3/16 rectangular tube. The uprights and the horizontals are 2 by 2 by 3/16 inch tube. And item 3 here, which you're going to encounter, no, not yet. Item 5 is a 2 inch by 6 inch by 1/4 inch steel plate, and it's drilled through for a 3/8/16 UNC in 2 places. The position of these are not given because it's not a critical dimension. You can pick the dimensions from the corners, and as usual, this would be As you can see, it's split. This is 6 inches long. You want 3 inches on this side and 3 inches on this side, and it's going to be bolted through on one side and welded on the other side. So one of the sides of the rack is going to have this plate welded out, and it extends over 3 inches to be bolted through and to the other side. So you're going to transport these two halves separately, because if you had the whole thing put together, it's going to be pretty hard to manhandle because it's going to be really heavy and it wouldn't fit in a pickup or on a small trailer or something like that. You want to be able to transport this once it's made easily with basically two people handling it. Now, this detail over here shows the joint. You've got square tube here and a square tube here butting up to it, and you've got a weld symbol here and a weld symbol here. I expect those to be included on your drawings. I expect the weld symbol here with a detail on your drawing, especially on your subassembly drawings. And as I said, you have a pretty much a partial material list. So if you come down here to, that's detail B, and it's going to be the same over here. We're going to have a 2 by 3 inch rectangular tube supporting this all the way across. This is the end view. So looking from either end basically would be an end view looking this way. And I put a break in it so that you notice it's 50 inches tall. It's 18 inches wide, center to center for the uprights. And this is your rectangular tube. It's 36 inches long. Again, the part numbers are on there so you can see them. The roof support, now I call the roof support a small little piece of metal here that's going to support the overall roof. So if you look at this end, if you look at this detail here, I put the detail C down here right below it. What you've got is you've got a square tube upright, you've got a flat steel plate that is welded to the uprights, and then this piece along with this piece and the roof support are one separate piece. So this is welded to the plate, this tube is welded to the plate, and this roof support is welded. And I've had the question asked, can you taper this so that it matches the roof? Yes, that would be a very finished look. You can also weld this roof support by welding here and here along that tube, and it would sufficiently hold it as well. Either way is correct. The angled top or peaked top is more polished in your design, and this shows that this plate, that these holes are 5 inches from the end. This shows a hidden line looking down on the top of this plate. This is detail D, and it's drilled through for a 3/8/16 bolt. And I'm going to let you determine the length of that bolt, because I don't think I gave a length for the, yeah, I do. So I've got 3/8/16 bolts going through and bolting these two together on both ends to hold this whole roof structure on. And if you go to the next page of this, well, that's what you were given by the customer. So I've given some additional sketches for you to augment this, and I call it an auxiliary sheet 3. And auxiliary sheet 3 basically shows you an ISO view of the rack assembly as it's finished, and I've called out the details. And this is the roof, which is wider than the roof support. The roof support comes out just enough on each side, so it's like 4 inches on either side, so you can bolt this roof section, because this is going to be it's going to be 100 inches long, or 108 inches, I think it's 108 long, that will bolt on after you get the whole rack assembly bolted together in place. So the overall length of the rack assembly is 100 inches. The overall height is 62 inches. And the roof itself is 100 inches long, 108 inches long, and the roof support has to be slightly more than 100 inches, because the center to this is 100 inches, and if you made that 100 inches, it wouldn't attach to this. So it's got to be about 108 inches as well. So let me go back to the final sheet that you've got. So this is an additional sketch showing the end view. I made a little more detail on the end view to drill through for at 5 inches. This is 18 inches center to center. So it's got to be, since these are 2 inches, it's got to be about 20 inches wide, so that it will come out flush and weld onto these plates. This whole thing is 9 inches tall. It's a piece of this 2x2, and with everything overall, it's going to be about 5 foot 2 inches, 62 inches. So that's the information you've been given. I gave you some notes to include. That doesn't necessarily mean that's all the notes you have to put in there. There may be some more. You're going to make a drawing for each of the components, and you're going to dimension the individual components, dimension the subassembly. You're going to have a subassembly drawing for 1/2 of the rack, the upright and the rack. You're going to have parts to make all these support components, those bars, all that kind of stuff. The connector, little 6-inch connector bar or tab, you're going to have a drawing for that to make it, and so on. All the details. And what I have given you is, because I'm not here to answer any questions for you, part of your drawing should look like this, which is a subassembly for an upright. And what I did is I left you a note. Left side is identical to the right side with the exception that the connector plate item 4 is not welded but match drilled for through bolting. And that means that over here it's welded on one side. It's offset by 3 inches. Let me come up here in the middle here so I can zoom. I've got the weld symbols, but you notice that this plate, and it's on both legs, is 6 inches. So you're going to have 3 inches over here and 3 inches over here. This side is going to be welded. The other side is going to be drilled. And when I say match drilled, the shop will put those on there. And when they go to assemble the two pieces in the shop, they will mark this plate. In fact, they'll probably drill the holes in this plate and then drill the tubing. When they'll clamp them together, they'll drill the tubing to match this, which means match drill, and they will assemble it with the bolts to make sure it all fits together. So this is what it would look like from the top, and that's one page of let's see. It's not what I wanted. I want page width. That's not what I wanted. Jeez. Okay. So I made my subassembly and parts pages as multiple sheet drawing. If you look at my drawing, it's got 3 or 4 pages for the subassembly and parts. I made my assembly as one drawing, which is more correct to do the assembly, and then anything additional. You can make individual drawings for your subassembly, individual drawing for your parts, however you want to do it. I personally think it's a little cleaner to put all this on a subsequent drawing with multiple pages, but that's a personal preference. So let's go back to the other sheet that I've given you for the upright. And this is what my third page is on my drawing, and it's all roof related. So here's the upright support for both ends for the roof. Notice I did not taper it, but you can. This is the roof support, and this is the actual roof. And it's 108 inches wide. You can make yours a little bit longer. What I'm perceiving here is a drip edge right here where it's bent down on a drip edge. So when you've got rain and stuff coming down, it'll come down and drip off and roll off, whereas this is just squared off because this is going to bolt through to here. And let me go in here and kind of show you what the intent is. Let's say 75%. So this is the roof support assembly with this piece welded to those two uprights that would bolt onto the overall assembly. And you match drill the roof for number 10 machine screws on a 9-inch center, and on both sides. So you've got holes along both sides over here and over here to match. Notice here, this has got a hole here and here, and this is here, there's a hole, and there's a hole here that match up to these two holes. So again, when I say match drill, they're going to build this assembly and drill it. They'll probably have some kind of a template and put it on there and drill it after it's all together. And then what they'll come through is they'll put this on the roof on, which has this drip edge. They'll put the roof on it, clamp it down, and drill it from the bottom so that it matches these holes. Or they may do it after they get it all clamped together. They may drill both of them together and then put the number 10s through, disassemble it for transport. So that's the intent of the project. It's due on the 30th by 5 o'clock. Hopefully by that time I will be able to grade it. If not, probably Dr. Goff will grade it using my template and rubric if I am still having a problem seeing clearly. As I've said before, I've enjoyed teaching the class and teaching y'all. I hope you have learned from this class. You'll be able to take it out and use it in pursuit of your career. And I wish you the best in your career, and I hope to see you around the campus again for future semesters. And that's it for today. Thank you.